Well, hey, let's uh let's keep our conversation going as we ourselves and exponents become good friends. Hey, today, we're going to be looking at an exponent rule, and this is the quotient rule that happens. So what happens when we raise a quotient to a power, when we have a division problem, going to a problem like, for instance, x over y to the third power. So that's basically saying it's x over y times x over y times x over y, which our numerator is x times x times x, which is x to the third, and y times y times y, which is y to the third. So this is like another like distributing situation, and we need to distribute the cube to both the numerator and the denominator. Because really a fraction is like a grouping symbol. When we talk about order of operations, PEMDAS, GEMDAS, it really is a grouping symbol. Our numerator, we need to tend to everything in the numerator, and we need to tend to everything in the denominator. And we run into this situation. In this case, power to power, um, our power in a quotient. Let's try some out. And keep in mind too, it can happen like fractions. We can distribute the fraction out, or if we have a fraction within our term. Let's keep going. Multiple choice here. Let's take a look at this guy. What is the simplest form of z to the 2/3 power over 5? So we have z to the 2/3 power over 5, and this is all being cubed. So I'm going to distribute the cube to both. Now, my power to power rule says that I just need to multiply. Now, really, 5 is 5 to the first. So I'm taking my cube and I'm playing it out on both. I'm distributing it to both terms. So let's see what we end up with. So z to the 2/3 power times 3 is z to the 6/3 power over 5 to the third power. And now remember, I'm simplifying this. So I'm going to keep simplifying. So z 6 to the third, that's actually, 6 over a third is actually 2. And that's staying there. And 5 to the third power is 125. Now this is fully simplified. I'm going to quick look and see if I have any negative exponents that I need to relocate, and I don't. All right, I'm going to have you try this. There you go. Why don't you try this 3? Press pause. Right. Take a look at your answers here. Excuse me. First one, nice and simple. I'm distributing that square out to both terms and using my power to power rule by multiplying. And this is 2 times 1. And so again, simplified, I got my 16, x to the 6th, nice. 2 ways to solve this would be to go ahead, and the first way is to distribute that 4 to both the numerator and the denominator and do some simplifying. And then I could use a quotient rule here of subtraction. And then I noticed that my a to the negative 17th power is not negative, but it is little, it's small. And so I simplify by completing my fraction without a negative exponent. The other way I did it is I took inside the parentheses and simplified my terms because they both had the same base. And so I had 3/4 minus 5 using my quotient rule and subtracted those out. I did have to change my 5 to 20 over 4, so I could do some subtraction on this one. I end up with a to the negative 17/4 power, which seems a little bit funky, but we're just going to keep simplifying. I use my power to power rule, and I multiply those here, and I continue to simplify out, and I get a to the negative 17th, which I can simplify out to 1 over a to the negative, or a to the 17th. You can write an expression in the form a over b to the negative n using positive exponents. Something we talked about before, and this is where we ran into like a situation where we have n to the negative 3 is written as 1 over n to the 3. Well, that can also happen when we have a fraction. So a to the b to the negative n can be written as 1 over a to the b to the n. And then I can distribute the n to both terms again. Now let's keep looking here. Now this dividing a fraction, so 1 divided by a over b, is the same thing as multiplying by its reciprocal. Some of you might remember calling that leave, change, flip, something like that. So that means I can take my numerator and multiply it by the reciprocal of the denominator. And because it's times 1, it's an identity property, so this is left. That's what I have here. So b over n equals a over n. And then I can like factor it out or undistribute and pull the n out. And I end up with b over a equals n. So we can see that from our long adventure through all this, that a over b to the negative nth power is the same value as b over a to the nth power. So this negative tells us it's small, which we can write this way, but we can transform it, we can build it all out, so it ends up being the reciprocal positive version of that. So that's a good thing that works out, and we got to keep that in mind. It's for all non-zero numbers a and b, and positive integers n. So that this guy is a positive integer. All right, we're going to keep simplifying. So we have 2x to the 6th over y to the 4th, and this is to the negative 3rd. Now, if you recall from the conversation we just had, what I can do is I can take the reciprocal of the fraction I have and change my exponent to positive. And this is going to equal the same thing. So now I'm going to use my power to power rule. After the 6th, now this is all being cubed. I have everything inside here. So I have y to the 12th over, now everything's being cubed, this piece and this piece. There's two different pieces being distributed here, so it ends up being 2 to the 3rd and x to the 6 times 3. So I'm going to keep going, can't stop this. Y to the 12th over 2 to the 3rd, so that's 2 times 2, which is 4, times 2, which is 8. And I have x 6 times 3, so it's x 18. And this is my simplified answer. So what I'm recognizing right away, and I want you to recognize that negative exponent, tells me that if I have a fraction in the parentheses, that I can use the reciprocal of it, but I need to change my exponent, my power, to a positive number. All right, I want you to give it a try. Pause. All right, I used the reciprocal, switched it to positive. I distributed the 2 out to every piece in my numerator, every piece in my denominator, and I end up with 25b squared over a squared. Excellent. All right, well, you have a great rest of your day, and I'm going to go teach my pet jellyfish how to fetch.